Alright, this can be a rather long lesson dealing with compound inequalities and absolute value equations and inequalities, although we'll mostly just deal with the inequality side of things. The processes are related to each other, which is why I'm doing in the same video. It's going to take us a while to get through all the stuff that's involved in the two inequalities. Compound inequality, what that means is you have two conditions that need to be met. So you have x is this or x is that, and then have to be able to get those two things together and be able to compare them. So dealing with a compound inequality, you want to isolate your variable just like we have been doing. You want to deal with each piece of the inequality by solving, and you want to graph each part by itself on the same number line. Then you need to consider your and or your or, and then you need to give the solution. So you know how to solve inequalities. We're now just going to do mostly two of them, and then how they're connected is with an and or an or, and we'll talk about the difference in those in just a second, and then you want to end up giving your solution. Alright, I want to talk first of all about the difference between and or. Say you go to the store and they have a free something or else going on, and they say you can take something out of this bag or out of that bag, and what that usually means is you just want something that meets one of the two conditions. It's this thing is okay or this thing is okay. If it goes and, you need to take something out of this bag and that bag, you're only good if you take something out of both. Right? So in the or situation, you might take your prize out of this one and then go on your happy way, or you might be a greedy little brat and take it out of both bags. Either way, you've met the or. You've met either one condition or the both, but you've at least met one of them. That's what or means. It means you have to at least meet one condition. With and, you have to meet both conditions. So, you know, in a situation like I have a glue that has two different sides to it, if you don't mix the two sides and the glue doesn't work. Well, that's the same idea of what an and is. I have to have stuff come out of this side of the glue, and I have to have stuff come out of this side of the glue, and then I can mix those together and it works. So I have to have both and in that particular situation in order to make it work. Alright, having said that, let's take a look at this situation. You have an inequality and you have it connected by the or. So what that means is x either has to fit this condition or it has to fit this condition. It does not have to fit both, but if it does fit both, that's okay. So we'll take a look at what it means. So we're basically going to ignore the or for a minute and just solve the two inequalities, which is easy. This one is x is greater than 6, and this one 3x is less than 3, so x is less than 1. And so my connection between the two is an or. Alright? Next thing I'm going to do is I'm going to graph these two guys. Alright? And when I go to graph these two, x is greater than 6. 1, 2, 3, 4, 5, 6. I graph like so. X is greater than 6, or x is less than 1. Alright? So now I'm just looking for the places where some value of x is used in order to solve the inequality. Well, this would be this value and all of those. And this would be all these values. So if this x were here, you don't have to meet one condition or the other. So this x counts. And this x counts. So this answer ends up being x. Actually, it ends up just being this. I started to write it again. X is less than 6 or x is less than 1. And the way that you would check that, you would check the 6, you would check the 1, you would check a number smaller than 1, and you would check a number bigger than 6. That's 4 checks. And for the sake of the length of the video, I'm not going to do that other than to suffice it to say 6 I know is a good cutoff point because I plug it in here and I get 12. 1 I know is a good cutoff point because if I plug it in here, that ends up giving me my negative 4. And then I plug in 0. If I plug in 0 here, it fails. If I plug in 0 here, that's going to be negative 7 is less than negative 4, which is true. So I know that my inequality is facing the right way that way. And on this side, let's say I plug in 10. 20 is bigger than 12, so it meets that condition. I don't even need to check the second condition because it does meet. So it shows me my inequalities are facing the right way, and it shows me my cutoffs. Now I did that verbally because of time and the space that I need to have here. You need to perform those checks. All right. Second example, I switched to an and this time. I'm going to ignore the and for a second and just solve what I have. So I'm going to add 7 to both sides. So I get negative 3x is greater than or equal to 18. I'm going to divide both sides by negative 3. So x is less than or equal to negative 6. Notice I switched my inequality sign. Alright, on this one's an easy solve. Now notice the negative 16 here. A lot of students are going to want to switch the inequality sign. Don't do that. I'm dividing both sides by positive 4. That's not an inequality sign switch. So x is still just less than negative 4. Now I'm going to remember I have an and in here. I'm going to graph this thing. And here's, I'll put 0 down here. 1, 2, 3, 4, 5, negative 6. Closed dot on negative 6 headed that way. Open dot on negative 4 headed that way. Now this is where I got to be careful about because this one's a little bit tricky. And I have to meet both conditions. Right? I have to satisfy this inequality and I have to satisfy this one. So what I'm looking for is a place where the graphs overlap. And so it's obvious through here that the graphs are overlapping. Now the question is 6 itself okay? The answer is yes, because it's a closed dot. It fulfills this equation because of less than or equal to. And so therefore my cutoff is right there. So actually my answer to this particular inequality is this piece. It's not that one. Negative 5 is not okay because it only fulfills one of the inequalities. So the check here is a piece of cake. You plug in your negative 6. Your negative 6 should go into this one, which would be 18 minus 7, which is greater than or equal to 11. And then I would check a number smaller than negative, so let's say negative 10. So that would be negative, by the way, I need to check it in this one also. The negative 6 in here would be negative 24, which is smaller than negative 16, so it fulfills both equations. And that's why the check's even here still a pain. Plugging in negative 10 is negative 30 minus 7, which is, sorry, that's 30 minus 7, which is 23. That is bigger than or equal to 11. And if I plug in negative 10 here, it's negative 40. That's obviously less than negative 16, so that's the case of what happens to be going on here. Which is, let's say we have negative 3 less than x plus 6 less than or equal to 20. All right, this is still a compound inequality. Now what this thing really means is this. It means x plus 6 is greater than negative 3, and this is always an and, meaning this thing is between here and here is basically the way you would say it. X plus 6 is less than or equal to 20. So you know how to solve this already. This is an example we just did. I'm not going to run through this method, but this is how you could break it up if you wanted to. You can also just leave it like that. You just got to be careful. The first time you're going to deal with 3 places. To get x by itself, I need to get rid of 6. It's x plus 6, so to get rid of the 6, I have to subtract. So subtract here, subtract there, and subtract there. Now if I were multiplying or dividing by a negative number, the inequality signs still have to flip. So all those rules still stay in place, but I can also deal with it in this situation. It also makes the answer nice and neat. This would be negative 9 is less than x is less than or equal to 14. The check on this is pretty simple. You want to check the negative 9, check the 14, and then check a number in the middle to make sure that it's all working. This will verify that the ends are correct and what's happening there. So if I plug in negative 9 here, I get negative 3, which is a match there. If I plug in 14, that's 20, so I get a match there. And then if I plug in 0, which is in the middle of that realm, that would be 6, which is bigger than negative 3 and less than or equal to 20. So this would be a correct answer. All right. Next thing I want to look at is absolute value equations and inequalities. Same thing, we're still isolating the variable. What we're going to have to do here is have to split the absolute value into 2 pieces. I'll show you how to do that. Decide on an and, or an or, and remember the term greater, and that lets you know which one's and which one's or. When you have a greater than sign in an inequality, you get greater, you get an or. When you have a less than sign, you get an and an equality sign always gets an or, it's this or it's that. And then we solve it like a compound inequality or like an equation. Now, typesetting, I want you to understand something. If you can't find vertical bars, this ABS is actually what your calculator uses too, so that was a good idea for me to show you it here. It really just means this, the absolute value of 2x plus 4 is greater than 4. Right? Now I'm going to explain a little bit about why it's greater, and greater gets the or. there are a lot of numbers that can make a value turn out to be bigger than 4. And so there's a lot of values that show up out there, and we're looking for big ones. And so normally it's really big numbers to the left and really big numbers to the right, and they're kind of heading away from each other. And that value, they're not going to overlap, so that's where the or ends up coming from. All right? So I'm going to show you how to split it. It's just like we did a second ago. I need what's in here to equal this, and what's in here to equal the opposite of this. And then I'll just switch the inequality. So split it into 2 pieces. 2x plus 4 is greater than 4. All I do there is I drop the absolute value signs. They're gone. Because this is greater, I get an or in there. And then 2x plus 4 is less than negative 4. It's like I divided by a negative number or something of that particular nature, and it just switches the inequality sign, and I get the opposite of the value of 4. Now I solve these and treat it just like a compound inequality. You saw a few minutes ago how to treat a compound inequality. So this is 2x is greater than 0. So x is greater than 0. Or 2x is less than negative 8. So x is less than negative 4. And then the graph of that with 0 in here, from here up is okay. 1, 2, 3, 4. From here down would be a graph. Because it's an or, it's all these values and all these values. So this thing turns out to be your solution. And your check again would be 4 things. Check the 0 and the 4, that lets you know your cutoffs are correct. Then you want to check a number bigger than 0, which is in the solution zone here, to make sure your direction is correct. And then check a number smaller in there in order to make that happen. And again, for video time, I'm not going to do those, even though I usually try to do those on the videos. This one I knew was going to be long. All right, last slide, dealing with one that's less than, just to kind of show you what goes on. So the absolute value of x minus 1 is less than or equal to 16. All right. So x minus 1 is less than or equal to 16. That's the same thing without the inequality sign. Because this is not greater, it's less than, it must be the other thing. So if it's not greater, or, it must be and. And that's just a way to try to remember, just a mnemonic device for trying to figure that out. X minus 1, switch the sign, change the sign. So I switched it from less than to greater than, and I gave it the opposite value, so it's got to be in between there. By the way, the reason this one's an and is because to be smaller than 16, there's not a wide range of values that are going to be smaller than 16. There's only a certain compact set of numbers that you can plug in for x that's going to give you an absolute value that's less than 16. So x is less than or equal to 17, and x is greater than or equal to negative 15. Those are my values that I'm looking for. This one's still a fairly wide range. If I go out here to 17, that's a closed dot on 17 headed this way. And down here I have a closed dot on negative 15 headed that way. And because it's an and, I'm looking for the place where they overlap. Notice my ends are closed because there's an equal to sign. So this is everything between negative 15 and 17. That's one way to write your number. I'm also okay with you giving me the number answer like that. Again, I actually only need 3 checks on this one. I need to check this end, and then check something in the middle in order to make sure that it happens. All right. I know it's a long video. I know I went through this one pretty quickly. This topic is fairly difficult. You might need to come in for tutoring on this particular and get some more input or feedback on it. Maybe watch the video over again and maybe catch something I said. There's a lot of information in this video. But they're kind of related topics, so I put them in one big long video. Don't forget your checks, even though I was a bad example here in doing that. Until next time, see ya!